We are in a briefing room in southern England, and the date is June 4th, 1944. Thousands of ships and aircraft are just marshaled and ready across the coastline. But the English Channel is entering this period of stormy, violently unsettled weather.
Right, and the calendar is dictating a pretty brutal constraint here. The invasion requires a very specific, highly restrictive combination of tides and moonlight.
Yeah, they need low tide near dawn to expose all the underwater mines the German army planted on the beaches.
Right, so the demolition teams can clear them. And they also need a late-rising full moon the night before to illuminate the drop zones for the airborne infantry.
So if they miss this narrow astronomical window, the next one with the right combination of tide and moonlight isn't for another 2 weeks.
And delaying means risking the entire secret of the operation. So standing at the center of this is Group Captain James Stagg, who is the chief weather advisor to General Eisenhower.
He has to look at these scattered, hand-drawn charts of the North Atlantic and deliver a verdict on the atmosphere. And that verdict forces Eisenhower into this binary choice.
Yeah, either delay the invasion and risk losing the only usable window, or send the largest amphibious fleet in history into churning seas that could, capsize landing craft and ruin the whole assault before a single shot is fired.
It is really the ultimate distillation of how we should interpret historical events. We usually study history as a sequence shaped by kings and generals, right?
Yeah, we memorize the dates of treaties and army maneuvers. But beneath all of that, beneath the grand strategies, is the physical reality of the atmosphere.
Because weather rarely changes history all by itself. What it actually does is alter the parameters of human decision-making.
That is the formula. It's always vulnerability plus meteorological forcing plus human decision.
That equation is what transforms a localized weather event into a massive historical turning point.
It is never just the wind or the rain. It is how a society or an army was positioned to receive that wind and rain.
Welcome to Meteorology Matters, the podcast exploring the science, chaos, and stories behind the weather that shapes our world. This show was created by meteorologist Rob Jones.
Today, we are examining the illusion of perfect weather, the myth of the invincible storm, and the moments when the atmosphere essentially audited the choices of human civilization.
And we are going to start by staying in that briefing room with James Stagg, because the meteorological debate happening behind closed doors leading up to D-Day really dismantles a lot of assumptions about how forecasting works.
For sure. I mean, the primary objective for the D-Day forecast was not to find a day with perfect, clear blue skies.
Right.
Expecting that in the North Atlantic in early June was a fantasy. They were looking for usability, not perfection. They just needed a barely acceptable threshold.
Let's establish the tools they were working with, too. Today, a meteorologist opens an interface and looks at high-resolution satellite imagery or, Doppler radar loops.
Or global numerical models running on supercomputers.
Yeah.
Stagg and his teams had none of that. There were no weather satellites in 1944. Radar was used for tracking aircraft, not precipitation.
So they relied almost entirely on surface observations.
Right, which meant hand-drawing massive charts built from decrypted enemy weather reports, observations from observers in neutral Ireland, and encrypted reports from ships scattered across the Atlantic.
And creating a forecast from this fragmented data sparked intense scientific friction between the different national teams in that room.
Yeah, you had two completely different philosophies of meteorology clashing. On one side, the British forecasting teams, led by Stagg, were heavily focused on the synoptic patterns of the North Atlantic.
Let's define synoptic patterns for a second. We mean the large-scale weather systems, right?
Yeah, the high and low pressure centers and the cold and warm fronts connecting them. The British method focused on the physics of the atmosphere. They were watching the real-time development of these massive pressure systems.
Trying to calculate how the clash between cold polar air and warm subtropical air would physically generate storms.
And how fast those storms would travel east toward the English Channel.
But on the other side of the room, you had the American forecasters, and they relied heavily on what we call analog forecasting.
Right, so instead of calculating the physics of the current storm, an analog forecaster looks at the current weather map and then searches through decades of historical weather archives to find a day in the past that looked mathematically similar.
The assumption is that if the map today looks like a map from June 12, 1910, then the weather tomorrow will behave exactly the same way it did back in 1910.
It's a statistical approach rather than a purely physical one.
Which I guess makes sense intuitively. History repeats itself. But the flaw there seems massive when you're dealing with the atmosphere.
It is a massive flaw. The atmosphere is a chaotic system. A historical analog is valid in highly stable climates. But the maritime climate around the British Isles is incredibly volatile.
Because it is influenced by the Gulf Stream and the positioning of the Icelandic low and the Azores high.
Yeah, the atmosphere there evolves far too quickly for a historical analog to remain reliable over a multi-day forecast. Two maps might look identical on Monday, but by Wednesday, one produces a light drizzle and the other produces a violent gale.
So Stagg has to manage this profound methodological clash. The Americans are telling him the weather will be fine based on statistics, and the British are telling him a massive storm is developing based on real-time physics.
And he has to synthesize this and give Eisenhower a single recommendation. He was translating scientific uncertainty into military risk.
And early in June, the synoptic reality wins out. The weather turns aggressively stormy.
Stagg advises Eisenhower that June 5th, the original invasion date, is going to be completely unsuitable. The winds will be too high, the cloud cover too thick.
So Eisenhower makes the agonizing decision to postpone. The invasion fleet, which is already at sea, literally has to turn around and hide.
But then Stagg and his team identify a temporary break in the weather. A short ridge of higher pressure is going to follow the main storm front, offering a brief window of calmer conditions on Tuesday, June 6th.
He tells Eisenhower the weather will be far from ideal. It will be overcast, the seas will still be rough, but it might just drop below the threshold of disaster. It might be sufficient.
And that moment is the crux of modern decision support. Stagg didn't offer certainty. He offered a precise risk analysis.
Let me put this in an everyday context for you listening. It's like looking at a severe winter storm warning and deciding whether to drive.
Right.
The forecaster can't promise you won't slide on the ice. They can only tell you that if you wait until tomorrow, the bridge will be completely washed out. You're not choosing between danger and safety, you're choosing the survivable danger.
And the conditions on June 6th validate that framing perfectly. The weather on D-Day was rough. Soldiers were violently seasick.
Heavy cloud cover forced Allied bombers to delay their drops to avoid hitting their own troops, meaning many German coastal defenses were left intact.
The winds scattered airborne units for miles. But the operation survived. It worked.
And to understand the value of Stagg's forecast, we have to look at what would have happened if they waited.
If they had waited for that next astronomical window, the fleet would have sailed right into a massive, unpredicted, extratropical storm that struck the channel on June 19th.
That storm was so intense it completely wrecked the massive artificial Mulberry Harbor at Omaha Beach. If the invasion fleet had been caught in the open channel during that storm, it could have been one of the greatest military disasters of the 20th century.
A forecast gave the Allies a narrow door to walk through. The military system provided the resilience to walk through it.
Which makes me wonder what happens when an army's logistics are already failing before the storm even hits. Because history loves to blame the weather.
It does. National memory often simplifies causation. It is psychologically much easier for a nation to accept that its grand army was defeated by a freak act of God rather than admitting to massive logistical failure by its leadership.
That brings us to a major theme, the myth of the invincible storm. Let's look at Napoleon's invasion of Russia in 1812.
The popular image is an invincible French army marching into Moscow, only to be frozen solid by a brutal Russian winter. General Winter defeated Napoleon.
But that narrative is heavily aided by Charles Joseph Menard's famous flow map, which links the shrinking size of the French army to plummeting temperatures during the retreat.
It is a masterpiece of data visualization, but it inadvertently cements the idea that the cold was the primary killer. The meteorological reality is vastly different. The destruction of Napoleon's army began months before the deep winter cold arrived.
Wait, really? Didn't they literally freeze to death on the way back? The paintings always show snow and ice.
They did freeze at the end, but look at the numbers. Napoleon crossed into Russian territory in June with roughly 600,000 men. By the time they reached Moscow in September, before a single snowflake had fallen, the army had already been reduced to about 100,000 men.
Oh, wow. So 5/6 of the army was gone before winter even started. What destroyed them in the summer?
The climate of the region and a total failure of logistics. We're talking about a continental climate which experiences extreme temperature swings. The summer of 1812 was blisteringly hot.
So the initial killers were heat stroke, exhaustion, and disease.
Specifically typhus. And the Russian army employed a scorched earth strategy, burning crops and destroying wells.
And then, before the snow, comes the mud. During the autumn, rain ahead of frontal systems saturated the unpaved dirt roads.
The freeze-thaw cycles turn these tracks into impassable swamps, and we have to analyze the physics of mud here. In 1812, an army was entirely dependent on horse-drawn transport.
Right, mud is a lethal hazard because the soil physically grips the wagon wheels. It slows movement to a crawl.
And it changes the biological math. A horse has to exert exponentially more physical force to pull a wagon through mud. That means burning significantly more calories.
But the supply lines were stretched, and there was no fodder left in the fields. The horses were burning massive energy fighting the mud and receiving 0 calories.
The horses died by the tens of thousands. Without horses, the French had to abandon their artillery and supplies. Mud is just as operationally destructive as snow. It just doesn't look as dramatic in an oil painting.
So by the time the severe sub-zero cold hit, the army was already dead on its feet.
Healthy, well-fed troops can survive severe cold, but Napoleon's soldiers were starving and wearing rags. The cold finished off an army that had already collapsed. The weather was simply a stress multiplier.
We see the exact same pattern of shifting the blame to the weather with the Spanish Armada in 1588. The historical slogan is that a Protestant wind defeated Catholic Spain.
Like a divine storm rose up specifically to save England. But the reality is the Armada's invasion plan hinged on a complex rendezvous with the Duke of Parma's army that completely failed.
The English launched fire ships into the Spanish formation at Calais. The Spanish panicked, cut their anchors, and scattered.
And once they scattered, the prevailing winds blocked their return down the channel. The only way back to Spain was to sail north around Scotland and south past Ireland.
Which took them directly into the North Atlantic in late summer. Let's talk about the meteorology there. We are dealing with extratropical cyclones.
Right. A tropical cyclone, like a hurricane, has a warm core and gets energy from warm ocean water. An extratropical cyclone gets its energy from the temperature contrast between cold polar air and warm subtropical air.
These storms feature rapidly dropping pressure, incredibly strong westerly winds, and massive ocean swells. And the Spanish ships are sailing into this heavily damaged.
Their rigging was shredded, their hulls were leaking, and because they had cut their anchors, they had no way to hold their position near the shore.
Plus the navigational limits of the 16th century, they had absolutely no accurate way to calculate their longitude, their east-west position.
They were sailing blind in terms of distance from the coast. The severe westerly winds were constantly pushing them east, toward the rocky coasts of Scotland and Ireland.
That is called a lee shore, when the wind is blowing from the open ocean toward the land. It is a death sentence for a damaged sailing ship. You cannot sail directly into the wind to escape, and the wind pushes you onto the rocks.
The Protestant wind did not defeat the Armada. Strategic errors did. The weather just turned a retreat into a maritime catastrophe.
And we can trace this dynamic even further back. The Mongol invasions of Japan in 1274 and 1281. This is the origin of the kamikaze, or divine wind.
Kublai Khan sent massive fleets, and legend says they were destroyed by typhoons sent by the gods.
The climatology of the western North Pacific makes typhoons highly probable. But why were the Mongol fleets so vulnerable in the first place?
Human engineering. After the first invasion attempt, the Japanese built a massive defensive stone wall along Hakata Bay.
So when the Second Fleet arrived in 1281, they couldn't secure an easy landing. The wall forced a tactical stalemate.
The Mongol fleet was forced to remain clustered offshore for weeks. They were highly exposed.
If that wall had not been there, the army would have landed quickly. A typhoon hitting a week later would have destroyed empty wooden ships on the beach, but the army would have survived. The human engineering created the vulnerability.
In all these cases, we see massive systems operating with zero margin for error.
Which brings up an interesting thought experiment. If the Spanish Armada or Napoleon had modern technology GPS, weather satellites, would it have saved them? Or would a perfect forecast just have shown them exactly how doomed their logistics were, days in advance?
It's the latter. Modern technology improves detection, but it doesn't solve a broken strategy. Knowing a freeze is coming in 3 days doesn't magically spawn 10,000 winter coats.
Military leaders make decisions for armies. But when weather hits a civilian population, the decisions made by governments become a test of their legitimacy. Let's examine the last mile of warning.
The Bhola Cyclone of 1970 is the perfect example. It struck East Pakistan, which is now Bangladesh. The death toll was between 300,000 and 500,000 people.
The meteorological setup is essential here. The Bay of Bengal has a very specific bathymetry, the underwater topography of the ocean floor.
It acts like a massive geographic funnel. The basin is wide at the south and narrows sharply as it moves north. And the continental shelf is incredibly broad and shallow.
A cyclone's primary destructive force is storm surge. The intense winds push water ahead of the storm.
And when that dome of water enters the Bay of Bengal, the narrowing coastlines compress it horizontally. The shallow shelf compresses it vertically.
The water has nowhere to go but up. In 1970, this surge was pushed into a low-lying river delta where millions lived just a few feet above sea level.
And the tragic part is, the detection actually worked. The ESA-9 weather satellite photographed the cyclone. The failure was in the last mile.
Right, the last mile is the fragile component of any warning system. The data has to pass through agencies, be broadcast on radio, and reach people on the ground.
In East Pakistan, that chain broke. Warnings were slow. Many people didn't have radios. The signal system was confusing, and even if they heard a warning, they lacked access to high ground or concrete shelters.
Evacuating meant abandoning livestock, which was their entire livelihood. We tend to think seeing a storm on a satellite at NOAA is the same as saving a life.
But an image on a screen doesn't build an evacuation bus. The atmosphere provided the hazard, but the communication gap provided the tragedy.
And the political consequence was seismic. The distant government in West Pakistan was perceived as slow and callous.
The slow relief response proved to the population that their government was incapable of protecting them. This resentment accelerated the birth of the Bangladesh Liberation War.
The weather audited the political system, and the system failed. We see weather as an accelerant to revolution in the French Revolution of 1789, too.
It is tempting to say a hailstorm caused the French Revolution, but that is reductive. It was a compound stressor.
Right. It started in the spring of 1788 with severe droughts stunting the wheat crops. Then, in July, severe summer hailstorms swept across France.
Severe hail requires intense atmospheric instability and powerful updrafts that suspend water droplets high above the freezing level.
The droplets freeze layer by layer until gravity overcomes the updraft. When a hailstorm hits just before harvest, it shreds the mature crops.
The drought weakened the crop, and the hail destroyed what survived. But then the winter of 1788 was brutally severe. A blocking high-pressure system funneled freezing Arctic air south.
The rivers froze solid, and if the rivers are frozen, you cannot transport grain.
And the water mills used to grind grain into flour froze solid too, so even the limited grain you had couldn't be milled.
The price of bread skyrocketed. People were spending up to 80% of their wages just on calories.
This highlights the difference between acute and chronic weather forcing. In Bangladesh, the acute shock exposed failure in hours. In France, the chronic rolling shocks tightened the economic vice over a year until hunger forced a revolution.
The severe weather exposed the deep rot in the social contract. Now, it's easy to blame a lack of infrastructure for a tragedy. But what happens when the infrastructure we do build creates a false sense of security?
The Great Mississippi Flood of 1927 is a masterclass in institutional hubris. You have to understand basin-scale hydrology.
The Mississippi River Basin drains a massive portion of North America. The 1927 flood wasn't one storm, it was months of relentless rain.
The critical concept is soil saturation. After months of rain, the soil becomes completely saturated. Every drop of rain flows directly into the river systems.
And the tributary peaks synchronized. Massive volumes of water piled into the lower Mississippi. But the human vulnerability was dictated by a levee-only policy.
For decades, engineers built earthen walls along the banks to constrain the water, thinking the increased velocity would scour the riverbed deeper.
But levee-only engineering prevents the river from accessing its floodplains. They didn't eliminate the flood volume, they just stacked the water higher vertically,
creating immense hydraulic pressure against the walls.
It's like putting your thumb tightly over the end of a running garden hose. You're stopping the water at the tip, but building up massive pressure behind it. When people looked at those levees, they saw a shield, but the river was just building up energy to break them.
In the spring of 1927, the levees failed in over 100 places. The resulting inundation covered millions of acres.
And the relief effort brutally exposed racial hierarchies in the Jim Crow South.
Black sharecroppers were forced to reinforce levees at gunpoint and were placed in guarded relief camps so planters wouldn't lose their cheap labor.
The flood revealed exactly whose lives the society actually valued. We see a similar theme of bureaucratic failure in Galveston, Texas in 1900.
Galveston was a wealthy port city built on a barrier island, mostly just a sandbar, highest point only 8 feet above sea level.
And the meteorology of the 1900 hurricane is textbook storm surge physics, a massive rise in sea level pushed by wind.
But Cuban forecasters operating out of Havana had actually observed the storm. They knew it was entering the Gulf of Mexico.
But U.S. Weather Bureau officials in Washington blocked them from sending warnings. The U.S. officials insisted their models were better and thought the storm would miss the Gulf entirely.
Meanwhile, the weather official in Galveston, Isaac Klein, noticed long-period ocean swells and dropping pressure.
The institutional warning system fundamentally failed. The storm struck with a surge up to 15 feet. The entire city was submerged. Between 6,000 and 12,000 people died in a single night.
But what the survivors did next is remarkable. They executed an ambitious civil engineering project to alter their vulnerability.
They built a massive concrete seawall, and then they actually raised the island.
They pumped sand from the floor of the Gulf of Mexico, piped it into the city, and literally jacked up the entire grade of the city by several feet.
So Galveston and the Mississippi floods are acute disasters, but what happens when the atmosphere changes the rules for months or years?
That is compound climate stress. Let's look at the eruption of Mount Tambora in 1815.
It was a VEI 7 eruption in Indonesia, but it wasn't just ash blocking the sun.
No, volcanic ash falls out of the atmosphere relatively quickly. The true climate-forcing mechanism comes from sulfur dioxide gas injected into the stratosphere.
The gas reacts with water vapor to form microscopic sulfate aerosols, and high-altitude winds spread these aerosols across the globe.
They act like tiny mirrors, reflecting solar radiation back into space. This slightly cools the global average temperature, which disrupts global weather patterns.
And that led to 1816, the year without a summer. Parts of Europe and North America had severe cold snaps in the middle of summer.
Bizarre frosts killed crops, leading to massive food riots and migration.
And culturally, the gloom trapped Mary Shelley indoors near Lake Geneva, where she wrote Frankenstein.
Right. But it's tempting to say the volcano caused Frankenstein. We have to be careful of environmental determinism. The volcano just changed the environmental parameters. Human beings reacted with their creativity.
We see human complicity in creating disaster clearly during the Dust Bowl of the 1930s.
Driven by a persistent atmospheric drought, often linked to transitions into a La Niña, pronounced La Niña, pattern, the Central Plains dried out.
But the lack of rain alone didn't create the black blizzards. To understand the dust, we look at the physics of a dust storm, specifically saltation.
When wind blows over loose dirt, it lifts heavier sand grains first. They bounce along the ground, acting like tiny hammers that dislodge microscopic dust particles.
And turbulent eddies suspend those particles thousands of feet into the air. But why was there so much loose topsoil?
Decades of human decisions. Driven by high wheat prices, farmers used mechanized tractors to deep plow millions of acres of native prairie,
destroying the deep-rooted prairie grasses that held the soil together. When the drought hit, the wheat died, leaving pulverized topsoil exposed.
And the dust clouds themselves altered the radiation balance, inhibiting rain clouds and making the drought worse.
Long before the EPA existed to regulate environmental practices, society had rapidly adapted to an unusually wet period. When the climate regressed to its mean, the system collapsed.
We look back at all these events and we have to ask, what does modern technology actually change?
We have amazing tech today. Ensemble models, Doppler radar, geostationary satellites. We can see a hurricane forming weeks in advance.
But a perfect forecast does not build a seawall. An ensemble model doesn't create a supply line. It only buys time for institutions to act.
Better forecasts make responsibility clearer, but they don't eliminate the disaster. The atmosphere audits the strength of the systems we build.
Which brings up an interesting dilemma for the future.
Yeah, if our AI-driven models eventually provide near-perfect prediction down to the minute, if we remove scientific uncertainty, politicians can no longer use unpredictable weather as an excuse. Every failure becomes a human failure. Are our institutions ready for that accountability?
It's a heavy thought. The atmosphere really doesn't write history. It just audits our choices.
Absolutely. If you want to keep exploring how weather shapes our world, be sure to follow Rob Jones on Instagram, TikTok, YouTube, and Facebook. And please take a second to like, follow, comment, and rate the podcast. It really helps other curious minds find the show.
It has been a fascinating journey examining the mechanics of the atmosphere.
You've been listening to Meteorology Matters, created by meteorologist Rob Jones. Thanks for listening, and remember, meteorology always matters.